welcome back one and all and everybody, and welcome to my new subscribers. Hopefully you've watched the previous videos. This is a part that was mentioned in the previous video, which is gussets and brackets. It's actually the rear gusset, not needed in what we're actually working on today, but the majority of the video is actually making it. The camera decided that it wanted to do something a little bit silly, and it reshuffled all of the video clips and put them in some stupid order that only it decided it understood. I've done my best to sort it out, but it's very hard to beat a computer, particularly when it has a mental breakdown. So anyway, the video was all filmed with the GoPro. I'm very happy with it. I just wish it had a zoom. That will be rectified as soon as possible. Anyway, what's happening at the moment? This is actually that part being milled to height, rectangular wise. The piece of metal you can see with all the holes drilled in the edge is just a pure piece of steel scrap that's about 5/8 of an inch thick, and it was just placed between the rear jaw and the piece of material just to give support, stop flexing, and hopefully cut back chatter, which is why it's so high above the vice jaws. It's 1.6 millimeter or 1/16 of an inch imperial, and I had just enough out of the piece that I had to make all of the 1/16 steel pieces for dart. So I don't want to mess any up, because that means I've then got to try and find another piece somewhere, and 1/16 is very hard to get in the UK. You can get it in America and you'll just pay a few dollars for it, but yes, there has to be a but. Shipping it across, you're looking at about $50 for a few dollar piece of steel. Not practical. You can get 1.5, and I suppose in the right places with a lot of hunting you could find 1/16, but you're probably going to pay for it because they probably imported it from America. But just did it en masse. So it's just a case of milling all these edges, taking a few thou. I think I was taking about 15 thou at a time off with a relatively sharp cutter that hadn't had a lot of use, so as not to catch, snag and distort it, rip it apart, and just do it nice and steadily. It took a good many days to do each part because unfortunately I had hospital trips and appointments and tests. Seem to be getting rather a lot of them. I use a hoover for cleaning up, sucking all the swarf up. It's a small workshop, and I have got a compressor. It's not hooked up at the moment, and the mill and the lathe between them throw enough swarf around the workshop without me blowing it into every nook and cranny. So I'd rather hoover it up, suck it into one place and get rid of it that way than blow it into every corner, particularly behind the mill, because then you've got to hoover it up anyway. Soft hammer just to tap the pieces down onto a parallel, making sure the parallels are nice and tight. That way you know you can measure from the top of the parallel to the underneath of the cutter, of which I actually am doing at the moment, just placing a bit of 3/8 inch brass, wind the head down so it's just touching, zero the DRO, and when you then mill back down to the zero, you know that the piece is 3/8 of an inch on the flange and at the correct size. And then it's just one more process to get it to the right shape, of which I mark up, mill down to the line or close to it, and then just finish by hand. Because it's 1/16, it's easy enough to take off the good file. Because these pieces were all cut from a big sheet with the jigsaw, the edges weren't straight, weren't square, and you'll see much later on when I do actually bend a couple of pieces. You don't actually see the bending, but you see the process, which is clamped between two heavy bits of steel which were milled square and vertical edges clamped very tightly, but one edge might end up as a different height to the other edge, so hence the process of milling them down to one height so that they're all ready to use. They were milled and then cleaned up with a soft with a mini tool and a wire wheel, sprayed, etch primer, keep the rust at bay. The corners were silver soldered for strength as per the plan, and there was only one bug, which was actually not this piece, but there was another piece which was made, and I thought, it's not quite right, and I just couldn't work out why. I'd made it to the exact size of the drawing, the numbers on the drawing anyway, and when I checked and I actually phoned the supplier of the drawings and asked them about it, they admitted, oh, there is an error there. Well spotted, thank you very much, we'll correct it at future drawings. So they are willing to alter and admit that there are errors. There's not many, just a few. So this is cutting the taper that you saw on the first, getting it down close to the line. You can possibly just about make out the line, about 10-15 thou at a time on each pass. Because the cutter was central, or the metal was central to the cutter, I could cut both ways, and it just means that the burr which it throws up will be one side or the other. Try and make so that the burr is to the outside, away from the flange, and it makes it easier to deburr. Didn't always work out that way, but take them down almost to size and then finish them off by hand, and then put them together in the vise and just make sure that they are identical, which they were. And then there's just holes to drill in the edges for when they get bolted onto some of the other pieces. Yes, the amount of work that goes in to these simple pieces is astronomical, but they do form a huge part of the chassis and are very, very important. People do not appreciate the amount of work that goes into the making and the hours that it takes just to make sometimes a simple part. And they think, oh yes, very easy. They don't realise that you're working to very tight tolerances, have to be extremely accurate so that this part will fit to the tolerances. If this part was wrong, it will throw something else off, and next thing you know, the foot plate just doesn't look right. It is a semi-scale model, so it's got to be right. Little errors will creep in, but you try and keep them down to a minimum. A bit earlier this evening I watched Joe make the latest part for his for the double 10 steam engine I sent him, and the accuracy that he works to. He actually did say that sometimes you can work too close a tolerance in parts just don't fit. And he actually showed it where he drilled a steam chest and he tried to fit it onto the studs one way and it wouldn't fit, turned it round and fitted it and it went on perfectly. That is pure luck, and as he's pointed out, it was just the wear in the drill throwing it off centre as it drilled the hole, and it just adjusted the studs that was put on. You need to see the video to watch, but if you've watched Joe, and I think a lot of my subscribers did come from Joe, so you've probably seen it, and you'll know that I'm full of admiration for Joe, and I just wish I could emulate him in the accuracy which he does. And he's had a lifetime of making to very high precision parts. I'm just doing my best, and I've been model engineering for nearly 45 years. This is not the first steam engine I've made, or steam train, and it probably won't be the last. I certainly hope not. So that's the 5/8 inch block of brass that I used. Just wind it down to just scratches the surface of the brass, and then I know that the height is 5/8. The previous one was 3/8, and yeah, just adjust accordingly. Now it's back to rinse and repeat and carry on milling the edges down. This piece was a bit of a enigma to hold, because the side nearest us is actually taller than the other end. There's probably 1/8 of an inch gap between the vice jaw and the metal, literally just at the far side of my finger. It would have been very, very easy to wind the vice jaw too tight and distort the piece, or even damage it beyond repair. It's a rectangular piece, and there's webs inside, all silver soldered together, and it's actually the bracket which supports the front step, so it has to be right, and it has to be very, very accurate. It's very difficult to see. I changed the light. I've got two working lights at the moment. This one is the more concentrated of them, and I will go back to the floodlight as soon as possible. What I've got to get is a way of supporting it so I illuminate down onto the piece. Parallels, so that I know that it's square to the vice jaws, and just a case of rinsing and repeating. Every part, every one of these pieces, although there's 20 pieces, there's 10 different ones, and there's a left and a right, so they're mirror images, but identical. Every one of the 10 is extremely different to the other one. Some of them are just simple L-shaped bits, and other ones are tapered. This is probably the most complicated of them to build up, because it is so many parts. It's the webs inside of the box, different heights, all the corners. I wasn't happy with the grip that I was getting onto that, so because it was 5/8, there was enough meat above the jaws to be able to put in lower parallels and get more grip between the jaws without putting too much force. If ever you've really needed to, you can actually exert a lot of force with machine vice jaws. A lot of force. You can do a lot of damage very easily, even distort pieces of tube which you think are solid because they've got a heavy wall. When you then measure them, you find that they're no longer round. I suppose it would be quite possible to do so with the cylinder of say a Stuart Turner, to clamp it tight into the vise and then bore it round, and when you take it out you find it's elliptical because you put too much pressure on. It's useful to know, and can be useful, but other times it's to your disadvantage. It does need a bit of care and a bit of attention. But yeah, lots and lots of boring parts. It was very boring for me to do, and as I said, it took several days to do each piece. Hopefully when they decide what they're going to do, I'll be able to spend more time in the workshop. It shouldn't be too long, but I'm pretty sure that all the tests are done now, and it's just a case of waiting and doing what I can when I can at the moment. As things move on, hopefully in a few weeks' time, there will be quite a change to the site, or to the platform, whichever you want to call it, the channel, and I will have a bit more incentive to do more. The next big change after that will be the fact that I want to upgrade the mill, get a slightly bigger one, and I will make sure that I get power feeds on the X and Y axis. I didn't spend too long on this part. We've all seen edge finding. Simple job. Measure one side, zero the DRO, lift it clear, come across, come down, wind it in so that it just breaks, check it a second time, make sure the numbers are the same, lift it clear, and then wind it back. Make a note of the numbers, of course, and WD-40 or acetone will remove Sharpie from metal, so don't be frightened to write on your vise. With the numbers written down and worked out, lift it clear, wind it right back. Well, you don't have to go so far as the first edge, but far enough to be beyond halfway, and then bring it forward to the halfway so that you actually take out any backlash. At least that's the way I do it, and I find it does work out very accurately. You can see the two drills that I'll be using. One is a spotting drill, 3mm, and the second one, the longer, is a number drill. I can't remember the number offhand, but it was certainly less than 3mm. So a case of just drilling with the spotting drill. If you're very lucky, you can actually get a nice countersink around the hole. This is the two bits of metal that are used to beat the 16th plate into 90-degree bends. The edges were milled square and straight, so any metal put in them can be bent nice and flat. And when the pattern was drawn, it left a larger flange than was needed, so it's just a case of milling it back so it's nice and narrow. This piece actually sits underneath the foot plate, and it goes the rear of the buffer beam, or on the front buffer beam to the rear, and supports the foot plate, so it holds the 90-degree between the foot plate and the buffer beam. And there's two bits of angle brass, which or would have been angle iron, between the buffer beam and this to sandwich it, give it support, and you'll see those bits being made in the next video. I had to order the brass. I discovered I didn't have any 3/4 inch brass, so ordered some courtesy of a favourite auction site. Buy it now. It was cheap enough, and for the length I need, hopefully I've got enough. I'll have to get another bit. Just done very slowly, very steadily, because I took it all off in one hit, back to the thickness that it needed. It's taking off about 3/16, I think. Edge milling, no problem, and taking it back just to make sure they get it right. With one piece done, I then put the other piece in and did it on the same settings so that they are identical. The two pieces were then placed back to back, clamped down with engineer clamps to a piece of MDF. I wish I had a aluminium pallet, but I don't. So I just use offcuts of MDF, which I have got a lot of. Seem to have collected them over the years. The 3/4 inch is nice and stable, and flat enough and strong enough to support. This is the number drill. I've already spot drilled it with it in the correct place, edge found it, of course, obviously set it up, and then just use the DRO to go from hole to hole. Drill 5 holes, some along the top. There's none in the flange at the moment. I presume there will be later to simulate the rivets between the footplate and the valance, but just a case of drilling all the holes ready for the rivets, or in this case rivet bolts. It uses dome head screws with the slot filled in, just to simulate a rivet. No, not a frog. We don't want frogs around here. But yeah, all the holes drilled so that they will be ready to go into place, and it should end up as a nice sub-assembly that will just be bolted onto the ends of the frames through the angle iron on the back of the buffer beam, and it will make a huge difference to the look of the loco. Also stabilise the front end for the cylinders, etc. So it's all very important, it's all very necessary. It's just a nice little job to do at the moment, just to keep everything ticking along. I didn't bother to film the drilling of every hole, but there's, I can't remember, there were 6, about a dozen. And the final part is this length of angle brass, which needs one edge narrowing down to be rivet screwed behind the front buffer beam. Again, I took it all off in one hit. This is just about the end. Thank you very much for watching and bearing with me. Part 2 will be finishing it up to the sub-assembly, getting it all ready to bolt in place, but it won't be till it's up on wheels. But thank you for bearing with me. Thank you for being here watching. Be safe wherever you are in the world. Some parts are decidedly unfriendly at the moment. I'm sure we know where. But thank you very much for viewing, and good luck wherever you are. Thank you very much.